We're good to go? Okay. All right, so let's just go through a quick intro to Python. So I think most of you guys are going to be using it for scientific purposes, so I'll just go through some of the syntax, common libraries that you'd use, and just like simple things like reading and writing from a text file and defining methods and functions and stuff like that. So if you don't know anything about Python, Python's a high-level programming language. It really emphasizes user code readability, and really allows you to just do advanced things quickly and with a short amount of work. So I don't know if you guys are using Python 3 or Python 2. They're pretty similar. There's just like some minor syntax differences. One of them, for example, is printing. So if you're using Python 3, then you don't really need to import this, have that first line in the IPython notebook that we're using. I should probably go through what is Jupyter Notebook or what is an IPython notebook as well. So it's just an interactive web application that allows you to basically go through scripts in blocks, and it's like really good just for lessons and following other people's code. So if you guys have it open, do you guys all have IPython open right now, or
yeah,
your notebooks?
You're using Python 2 or 3?
I'm using Python. I'm using Python 2. Yeah, so that's why I have that that first line in the top, from future import print function. But
you need to change your screen so it should work on the
it's not showing on the projector.
Yeah. So I think there's like a
Mirror.
function in the little icons.
Usually there's like a workspace or something, right?
This button here.
All right.
Did you function on that button?
Yeah, we're good.
Awesome.
Sweet.
What was that? No, which folder is it in? So if you download the intro you go into, if you have the link to the website. I have the email that I sent 2 days ago. Okay, so the link to the GitHub issue. Yeah, so I have which folder is it in? It's in the intro for
I think I just attached it to a comment in that on the.
Yeah, so if you go to events and then, okay, it's not up on the website yet, it's just a link to events. Okay.
No problem. So I can wait. Like you can just cut this out from the video or something. we can wait, or should I just continue?
Give it like a minute. But
Okay. I think I added like one additional section while I was waiting for you guys. So I'll upload that later, but it's basically just reading and writing from files.
and it's called, it's the .IPython.
Yeah, it's a zip file. You just gotta.
Yeah, I
Yeah.
got it. I'm just
Opening up.
opening Jupyter.
Okay.
You can keep going.
The beginning is pretty easy, so you should be fine skipping it even. All right, so I'll just like start it. So you can basically just go through the notebook just by running each cell one by one. So we'll just run the first example, print hello world. So as you can see, you just write whatever string you want in there, run it. Yeah, output hello world. So the main data types that you have in Python by default are numbers, which are integers, floats, strings, lists, tuples, and dictionaries. So I'm going to go through each one of these one by one. So starting off, what we have here is just like a few examples of arithmetic in Python. So 2 plus 2, we have decimal 12 point, and then just means it's a float times 3. It also comes in with complex numbers by default. So if you guys know what a complex number is, should be pretty straightforward. So one thing to note is that in Python 2, integer division will automatically give you the like the floor division. So it's basically just gonna get the integer part from the quotient. So essentially, the remainder is not going to be there. So 1 divided by 2 in Python, you're going to get 0. So continuing with this, if you want to deal with precision in Python, you can use the round method, which allows you to just, in the first example, it's going to round to the third decimal. In the second example, it's going to round to the first decimal. Just running this, you can see 5.3, 5.2, 5.4. Continuing, here is an example of an integer. X is just defined as an integer. Y is defined as a float, storing a float in it. Z is a string. So if you want to find out what the type of the given variable is, you can just use the type command. In IPython, you can also just use like these magic functions, which one of them is just putting a question mark at the end of it. So if you're using IPython, which the Jupyter Notebook is running that in the background, you can use a question mark, and you should get this box that pops up at the bottom, which gives you some information about the variable. So you have type int, which is integer. If you want to get the documentation on a method that's in built in, or a method that you've made in another script, you can also use the help function. So running that, for example, we'll get a bunch of information about what the type method is. So you can read that, get some additional information. So if you want to print a string with a given variable as a part of it, you can do that fairly easily in Python. So here's an example. It's pretty user-friendly. So you have a string. This is a string, and these are integers. And then you can just basically place the variable x in there. You can manually input a number in there as well, and then running that, we could see that you get what you want. It's pretty straightforward. Another example, if you want to have multiple different variables printed out at the same time, you can do it this way, which you basically have these kind of placeholders where you'd have to actually put in what type of variable it is. So the %i is indicating it's an integer. You have another one here. So running that, it would basically input the x1 and x2 in there for you. You can also just manually concatenate a string. So you have a string here, and this str function basically converts whatever's in there into a string for you. So running that, you should get identical results for both, which you do. So in general, if you want to concatenate a string in Python, you can just use the addition operator, and it's pretty user-friendly. Hello, Grasshopper. So string replacement. So if you want to replace some substring in a string. So for example, we have "you're great." We can replace that. We can replace "great" with "horrible," and we'll get "you're horrible." In Python and in a lot of languages, strings are usually represented as character arrays. So just to illustrate this for you, we have a few different things that we're looking at. The first one is, what is the length of the string? Second would be the first value in the string array, the character array. So for one thing, in Python, all arrays or lists are always indexed starting from 0. So in other languages, like in I don't know if you've worked with MATLAB, it's indexed from 1. So it's good to know these things. If you want to output everything up to the fourth character or the fourth element, you can do 0 to 4. You can do from the 5th to the 7th. You can do everything starting from the end, going from, you just have a negative sign, and it'll output starting from the end down to the 8th character from the end. So just running these, we can see the string is 16 characters long. Everything else works as it should. So you can also do like if you can also kind of use different operators with strings. So s times 10 would basically just reproduce the string 10 times. So if you want to get a feel for logical operators in Python, we can just quickly go through this as well. So we have two variables x and y, which are both integers, and we have a string as well. This is a string. So we can test things like, is x equivalent to 5? Is x equivalent to y? So what we can see is, running this real quick, the output is a Boolean true or false. So we could see, for example, that this is essentially is not equivalent. You have the less than operator. You have less than or equal to operators as well. So it's fairly straightforward. So one thing as well is you shouldn't use only one equal sign, because that's kind of, if you want to define a variable, then you'd use one equal sign. If you want to check for equivalence, you'd have two equal signs. You can also do conditional statements. So if x is less than y and y is greater than 7, then it's going to output true. Otherwise, it'll output false. Likewise with the or. So running this, you can see that x is less than y, 5 is less than 10, and y is greater than 7, so it's true. And x is not less than, or yeah, x is not less than 4, and y is not less than 4, so yeah, it's going to be false as well. So the kind of main data types in terms of in Python are going to be lists, tuples, and dictionaries. So just kind of summarizing what these three different data types are. So a list is a ordered collection of values, essentially, and it can hold any types of any data types in it, any of the default data types. So it can hold numbers, strings, characters. So once again, it's indexed starting from 0, and they're mutable, which means that the values can be reassigned as you go. Tuples, on the other hand, are similar to lists, and with the exception that they're immutable, which means they can't be reassigned. So they're going to be essentially fixed from fixed values from the beginning. They're slightly more they're more memory efficient. They allow for faster assignments, but in terms of lookup times, they're pretty much identical to lists. Dictionaries, on the other hand, they're in the background. Essentially, it's a hash table, and they're unordered collections of keys and value pairs. So keys and values can be any data type, similar to the other cases. So they have the fastest lookup speeds. So if you know what the kind of the big O symbol means, it's essentially how these things scale with the size of the lists or dictionaries. Is you'd understand that having an O to 1 is much faster than O to n in terms of lookup times. So continuing with this, let's see how a list operates. So I defined here just a list with integer, character or string, another integer, a float, and string. So just to illustrate that it's pretty flexible in terms of what type of values you can store in it. So going through it, if you want to see the length of the list, you can use the len method. If you want to print starting from the third value, you would start off with going to colon, and that prints everything after the second value. You can essentially combine lists to get just through the addition operator. And similarly, if you want to get the index that of a given value, you can use the mylist.index method. So continuing with that, tuple, I've defined essentially the same values in a tuple. You can use similar thing, length, same length method, and indexing the third value is essentially identical to a list. So continuing with a dictionary, so as I was saying before, you have your keys, and then you have your values, and each one is a pair. So each linked to each key is unique, and it's linked to a given value, which is not necessarily unique. So over here, I've added a new key and value pair. So I have inserted essentially a list as a value into the key dog names. So running this, what we can see is the output is, this is the list from after this point in the in this block. So you can see that dog names is mapped to this list. You have dog number, which is mapped to 47, and dogs, which is mapped to capital dogs. So printing, just like if you want to just call a specific key and see what the value is, you can just do it by this syntax here. Similarly, if you want to delete a key and value pair, then you would just use the delete method there. So as you can see, after deleting the dogs key and printing out the dictionary again, you can see that there's no longer, it's missing that from before. So one thing that you got to be kind of careful about is kind of how when you're reassigning, if you're copying a list or copying a dictionary, or if you're reassigning it to another variable. So for one thing, you got to know that the fact that lists and dictionaries are immutable, and whereas for example, tuples aren't, or integers and strings and floats are immutable. So this kind of related to this is the way that they're actually stored in memory and how they're actually they're called. So just taking a quick look, it's probably easier to just learn this just through demonstration. But so what we have here is a list that's defined as just got two different elements, which are both strings, alpha and beta. So if we assign y equals x, and then we print it out, and then if we reassign the first index of y to gamma, so if you guys, what do you guys think will happen here? Actually, you probably already run it, so you already know the answer. But one thing you'll notice is that changing the value in y automatically changes the value in x as well. So the reason why this is because essentially in the background, the way lists and or the way that lists are kind of, you're calling that variable is by reference, which means that you're essentially these variables are storing memory addresses, and you're essentially just calling that, seeing what the value that memory address is linked to. And so by changing one, you're automatically going to change the other. So in order to see this better, what we can do here, an ID function here, ID method, which returns essentially the identity of that memory location, which is associated with the variable. So calling this, what we can see is that they're both the same memory address, which makes sense, and that kind of explains why changing one will change the other. On the other hand, what we can do is, so normally you'd use a method called list, but for some reason it wasn't working. I don't know why, but there's another method that's copy, that's just more general, and that works with basically all different types of data structures as well, not just lists. So what you can do is import this copy module, and instead of just assigning y equals x, we can do a copy of the variable, and running that, what we should see is that changing a value in the y list will not change the value in the x list. So looking at doing the same thing and looking at the memory, the two memory locations for the two different variables, what we can see is doing a copy assigns a different memory location. So now we have two different variables that essentially operate independent of each other. So as you can see, so before over here, I just imported some module copy. So let's look into that a little bit more there. So libraries are essentially imported through the import command in Python, and a module is, you can just literally think of it as a file that contains other methods and associated statements. So you would save, for example, you can create your own modules, and you do this just by having the module name and appended with .py at the end, and you can call that on your own if you want it, and you can call those call any method inside that module. So popular modules for scientific purposes that you've probably heard about are Numpy, SciPy, Pandas, which is for data analysis, and matplotlib, which is essentially the main plotting module in Python. So just to see how you would do this. So for example, going into, also inside that same folder that you guys should have is another Python script called Fibo. So just to check that out. Can you see this in the screen? Yeah. So we have Fibo here, opening that and seeing what's in it. We have essentially two different methods. We have the fib and fib2. So it doesn't really matter what these are doing, but if you want to know, they're just basically outputting the Fibonacci sequence up to the nth series point. So seeing this, so we have import Fibo, and we'll just run the fib method, call the fib method inside that module. We could see that the output is what you'd expect. So Numpy, which is another, which is like essentially an external module, so it's not something that you just made yourself right now. We can use if you guys don't have it installed, then we can do this try and accept conditional statement, which essentially it'll try to import it. And if you don't have it, an error will pop up and it'll essentially print out the statement. So let's just like open up the, just run that. I have it, so I'm fine. And what I have here is just an example of how you define a vector array in Numpy. So another example, if you've worked with Numpy before, if you want to create a two-dimensional array that's 10 by 10 and it's all zeros, you have it there. So continuing down, we'll go into loops and conditional statements in Python. So just a simple for loop. You have for I going from 1 to 10. And one thing you'll notice is that it doesn't include 10. It goes up to 9 essentially. So just be aware of that. If you want to go from 3 to 10 in units of 2, you can also do that. So 3, 5, 7, 9. If you have a list, you can go through each element in the list by just going for item. It doesn't actually have to be item. You can have any just placeholder variable, which makes sense. And I just printed out what my list was. We defined that earlier. If you want to search through a list for a given value, for example, you can test. You have an if statement here. If item is equivalent to 5, prints 5 found, and then it breaks the for loop, so it leaves the for loop, else print not yet. And we have a while loop here, which essentially while I is less than 10, it'll keep going through this loop iteratively, and once I equals 10, it'll break. And in this, all we're just outputting is I squared for values that are between 5 and 8. So how do you define or how do you declare functions or methods in Python? So here's a quick example. You just have your def, the name of the function, and then whatever arguments that function would take. So looking at this, we have, we're essentially just taking in X and Y as arguments, and we're printing, inputting into the string, doesn't really matter what it says. And then over here, we're outputting X times Y. So just running that, and you can call a function just by its name and then having its arguments in there. We'll just skip that. So one thing is having these 3 quotation marks at the beginning of a method will essentially allow you to, if you ever use the help method in Python, it'll output anything at the beginning that's within these 3 quotation marks. So just running that, we'll see that this is pretty useful. So if you ever write a program and another person wants to know what is this method doing, you'd want to put that in there so they can essentially know what each method is just by calling the help function. So another thing is, once again, immutable types. So if you have a variable x which is immutable, which you can't change, like it's similar to the discussion I was talking about before. Once you call this function, you change it outside of the outside of that method, it's going to stay the same. So it's essentially, this is a local change only in that method. So as you can see, we inputted 2, we reassigned x equals 10, and it didn't apply globally. So on the other hand, if you wanted to do that with a list, which is a mutable object, what you'll see is it will change. So once again, if you want it to not change, so you want it change, like things to only change within that local scope of that method, then you'd want to send a copy of that list to the method instead of just the variable itself. So as you can see, so we sent to it first, second, third. Coming out, we have first, changed, third. So I don't think you guys have this section, but it's pretty straightforward. So if you just, I'll upload this reading and writing to text files later. But so what we have is the way, you have 2 main ways of opening and changing or inputting and outputting to text files. The best way is using this syntax here with open, and then the file name, and then if you want to read, write, or append, and there's a few other options that depend on kind of like the like if you want to output it as a binary text file, you can. There's other options like that. So the main ones would be read, write, and append. So over here, I'm just going to read this file text.txt, which is located in the same folder as the main path that we're working in right now. So I can just load it in. So you essentially create, open up the file, and it's stored in this file handle. And then you can call a bunch of different methods from that file handle. So readlines opens everything and just stores it all into this text. So printing that, we could see that it stored everything in this text file into that text variable. So let's see what that is. So we have 5 lines, and it stores it into a list with each index being each line. So if you wanted to read, go through each line one by one, you can just use the for line and f handle, file handle. Shows it there. If you wanted to output to a text file, you can do the same thing. Just change, instead of read, you have write, and you can use the file handle .write to output, which I'm outputting it to a file called output filename.txt. So we should see that string that I wrote. This is a random string. This is a random string. So the other way that I was talking about, where you would, the good thing about using this syntax here with open as whatever file handle name you want, is that you don't have to close the file at the end of operation. So if you wanted to do that manually, then you'd have to basically use this method here, where you first open it, and then at the end of working with whatever you're doing, you'd have to close it manually, and you get this exact same results as before. This is an example text file. Yeah.
So is there any advantage to opening the slides that you have to
no, not really. But forgetting to close a file is like it's just like the Python way to do it. Kind of the Python ways to do it is the way that is like the least prone to like screwing up.
Everything you're doing with that file has to be underneath the open?
Yeah. So yeah, it's everything within the block indent. That's going to essentially be.
So, I mean, it could be annoying from tons of stuff.
Yeah. So the whole issue is like, while it's open, that's going to be like you're essentially wasting like part of it is going to be stored in your memory, and then also like if other people want to access that file, then you have it open, that's going to be an issue. So essentially, you want it to be closed as soon as possible, and this will ensure that. Yeah. But I mean, there are cases where you want to use this way. Yeah. So going to the end, you can also define functions within functions. Just looking through here. Just pretty self-explanatory. It's the exact same syntax as the main functions, just literally inside of it. And class definitions are also quite straightforward. So here, this first line is basically going to be called by Python on the initial instance of essentially defining the object linked with that class. So you don't really, so basically these are your attributes. You have self.name, self.department. You can call these attributes outside once you've created the object. And Jane says hello. Yep. All right, well, it's pretty much all I prepared. I hope, I think like at this point, you should be able to learn everything else just through scrolling Google and documentation and working things out yourself. But this is pretty much the basics that you would need moving forward.
Practice.
Cool.